Case 2 is two bodies are connected by horizontal string are placed on a smooth horizontal plane. So we've already done it. So इसमें M2G this way. The tension there will be in this. This is T for this, and this is T and F for this. So we have two different entities. This is a different entity, and this is a different entity. So we have two bodies connected by a string. So this is M2G. N2 is equal to M2G. N2 is equal to M2G, and N1 is equal to in this direction it is F sine theta. So vertical equilibrium. So in accordance with the vertical equilibrium, So the two bodies are connected by a horizontal string, are placed on a horizontal plane and pulled by an inclined force. So force is inclined here. So this is already explained. This is, we will take this triangle. This is 90 degrees. So this is like we take f of x, and this is f of y. So f of x is in this direction. So this will be the base. This will be the base. So what is the sine theta value here? Sine theta is equal to sine theta is equal to sine theta is equal to p by h. So what is p by h? Perpendicular. This is perpendicular is f of y. Perpendicular is f of y. P by h. H is this one. This is force F. This is force F. So this is f of y divided by force, because this is h, hypotenuse. So this is p by h. So if we take in this cross multiplication, if we do the cross multiplication here, so f of y is equal to how much? F of y is equal to f sine theta, equal to f sine theta. Sine theta. Theta is the angle. Theta is the angle. So Fy is equal to f sine theta, and f of x, now we have to find out cos theta here, and cos theta is equal to b by h. Cos theta is equal to b by h. B is, this is the base, so f x, b base by hypotenuse, base by hypotenuse so if we take in the cross multiplication, cross multiplied, then f of x is equal to f cos theta. F of x is equal to f cos theta. F cos theta. So this is in x direction, x direction. This is f cos theta, and in the y direction it is written here f sin theta. Should drop it here. This is f sin theta now. Just circle it up. And this is here. So f sin theta. So when the two bodies are connected by a horizontal string, are placed on a smooth horizontal plane and pulled by an inclined force. The force is here is in this direction, and the body is pulled in the horizontal direction. So MA will be in this opposite direction. This is M1A. This is for this body, M1A. M1 into A. And for this body, this will be in the opposite direction. This will be M2A. 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 So the equation formed here will around like in the for the vertical equilibrium, for the vertical side we are considering this direction, vertical direction. So there are two things we have to concentrate. So in the vertical direction kya hai? This is f sin theta. One is the f sin theta. So f sin theta is in this direction. So f sin theta, f sin theta in the vertical direction we are considering it f sin theta, and f sin theta, and this is n1 f sin theta plus n1 plus n1 f sin theta and plus n1 is equal to m1g because in this whole chart, the vertical plane, there are two things. N1 is this one and f sin theta in the same direction, and M1g is in opposite direction. So we have to consider it. N2g now. So N2 is in this direction and M2g is in this direction. So N2 is equal to N2g. This is written M2g. N2 is equal to, so we will write N2. What is there? Rubbing is all because I'm not able to understand now how it came at us something. So we have to now rubbing this up. Everything is clean now because it was very hodgepodge. So I thought I would just notice all these things. So now we have to consider N2. So N2 is equal to M2G. N2 is equal to G. and here it will be n1 plus f sine theta, n1 plus f sine theta sine theta is equal to m1g. So you have to remember this chart, this diagram. There will be two tensions, one in this direction, one in the opposite direction. So this tension is for this body, and this tension is for this body. So there are two tensions. You have to remember this thing. Vertical, horizontal के लिए क्या हो जाएगा? Horizontal के लिए हम लोग फिर से इसको dub it because we are not able to get it according to one. This is to be rubbed now. Now for the horizontal acceleration, what will be the equation for this? For horizontal, for horizontal acceleration equilibrium equation of m1 and m1. For horizontal horizontal acceleration of m1 and m2. Horizontal, what will be the equation in the horizontal direction of the acceleration of m1 and m2? There are two bodies, so there will be the two different equations will be formed. So horizontal acceleration, we have for this body we will consider this body. There are two bodies, so this tension is for this. For horizontal, f cos theta, and acceleration is in this direction. So in this direction it will be m1a. So in this direction it is m1a. So this will be t plus m1a. T plus m1a is equal to f cos theta. T plus m1a. T plus m1a. Because horizontal, we are considering horizontal acceleration, and we have to make the equilibrium horizontal acceleration equilibrium equation. So n1 plus f sine theta, f sine theta n1 plus f sine theta is equal to t. So this is the first equation, but here it is given f sine theta. This is for the vertical now. So horizontal, we are considering horizontal is m1a and f cos theta. For horizontal, we have to consider t plus ma, t plus m1a is equal to m1a is equal to f cos theta. F cos theta is in opposite direction, so it will be equal to f cos theta. F cos theta. Please like my channel and subscribe it, as I will get boost of it. And this is t plus m1a is equal to f cos theta. So f cos theta minus t. m1a is equal to, so m1a is equal to f cos theta minus m1a. F cos theta, f cos theta f cos theta minus t. So we get this horizontal equation, which is given at the bottom of it. This is the equation. For vertical equilibrium, we get this. For the horizontal, we got this. Case 3 is two bodies are connected by an inclined string and plane. This is an inclined plane. So the mg will be in the downward direction. So two bodies are connected by a string made to accelerate up the incline by applying force parallel to the incline. So this is how to take came, because I have explained it already. This is the, where is the theta? Theta is here. Let's say here is the theta. So this is f of x. To place it here. Tension of a rod, physical applications, pillar, I will explain it. I should explain it. When rod is attached to the pillars pushing the house in the upward direction. Physical application, tension of the light rod. To accelerate the applying force to the incline, parallel to the incline. There it is. Two bodies are connected by a pulled by the inclined plane. So this is like so this is the two bodies. These are the two bodies that are connected by an inclined string. And here they are placed on a smooth horizontal plane and pulled by an inclined force. So this is the inclined force. The force is here is inclined, and the string is inclined also. So this is a string. Two bodies are connected by inclined string and are placed on a smooth horizontal plane and pulled by an inclined force. So this is a string by which they are attached. Two bodies are attached by a string, and this is a string, and they are pulled from this point. They have been pulled in this inclined direction, and the string is also in the inclined direction. The two bodies, this one body is attached with the second body with an inclined string. The string is inclined at an angle of theta, and here also they are attached. The string is pulled in this direction, and that is at an angle of theta to the horizontal. We have done, this is theta. So for the vertical equilibrium, there is a tension between these two. Like we have this is a string with accelerator. This is a triangle like this. So we can draw a triangle, bigger triangle, so that you can understand this now. You can understand it. So here, like this is a tension, T. This is T. For this block, this area is to be considered. For this block, this area is to be considered. So there are different areas for the different blocks. Like this is a one block. So whenever we were making the equilibrium equation, we have to consider this area, this whole area. And when we are considering equation for this block, then this area will be considered, because there are two different areas to be considered for making an equilibrium equations. So this is we have to make the rectangle where this is tension T, here is this tension is T, and this is like angle theta, this is an angle theta. Okay, make it. This is an angle theta, and this is T of x, like I make it like T of x. This is perpendicular, so this is the base, like this is T of x, I will now give it T of x, and this is T of y. So what will the value of the sine theta now? P by h. P, this is P, and this is h. So sine theta is equal to sine theta is equal to P by h. P is Ty. Ty divided by T. So we will consider it into cross multiplying it. So Ty is equal to T sine theta. Ty is equal to T sine theta. So in this direction it is given T sine theta. How it came? Because we have to see where it is, like T sine theta and T cos theta, in which direction we have to mark. So this is the calculations of the sine theta and cos theta. So now I will consider it as cos theta. Now this is over. So what is the cos theta value here? What can be the value of the cos theta? What will be the value of the cos theta here? Cos theta is equal to b by h. So base is, this is the base, T of x. T of x divided by, this is T, and the vector form we consider this T. We cross multiply this here. So T of x T of x is equal to T sine theta, T cos theta. T cos theta, T cos theta. So this is TFX we have found out, and already we had found out TY. So in this direction, y direction is T sin theta, which is given here, and in the x-axis it is T cos theta. So we have x-axis and the T cos theta. So this is the way we have to how to calculate the things from the y-axis and from the x-axis. I'm rubbing it because I have to consider. So next is this is f of x. Here it is given. So how to calculate it? We just go for this triangle. This is the base now. This will be the base. So sine theta is equal to p by h. P by h. This is p by h. This is p. We consider that f of y, and we consider that f of x. So p by h is p is f of y. Divided by f, p by h. So cross multiply it. F of x is equal to f sin theta. F of y is equal to f sin theta. F sin theta. So in the y-axis it is, here you can see y-axis it is f of sin theta. Now we consider it f of x. F of x is equal to इसमें आएगा cos theta. Cos theta is equal to b by h. So b is f of x. Cos theta is equal to b by h, base by hypotenuse. So what is the base here? Base is f of x. F of x divided by f divided by f. So this will be cross multiplied here, cross multiplied. So f of x is equal to f of cos theta. F of x is equal to f cos theta. F cos theta. F of x is equal to f cos theta. So you can see here, this is in this x-axis, y-axis it is f of sine theta, and in the x-axis it is f of cos theta. We're just rubbing it up a lot. So this is the exact diagram of it. You can see here that there is an inclined string. This is an inclined string. This is an inclined string here, and here also the force is applied in the inclined direction. So how to make these equations in the x-axis and in the y-axis? So how you make the equilibrium equations here? That is the main point here. So you make the equations. I'm coming in 5 minutes time. I'll switch on the videos also. This is Divya. Divya. Class 10th. This is for the class 10th. Class 10th for the test, or we can do the practice also. So maths की practice है ये. This is a practice for maths for the class 10th. Class 10th की maths की practice है ये. Suppose करो triangles. Pair of elevation. Start practice maths. So here this is the question, you have to solve it. In a triangle ABC, this is a triangle ABC. So AD is the bisector. This is the AD is the bisector of this. So AD is the bisector of angle A. Meeting side BC at D. If AC is equal to 4.2 centimeters, DC is equal to 6 centimeters and BC is equal to 10 centimeters. Find AB. You have to find AB. AB you have to find. So you can continue tomorrow also. Thanks for watching. Thanks for your support. Please subscribe my channel and like my video. Thank you. Thanks for watching. It's the Spring Labs actually.